We will wait, sir.
Video.
Okay. Once again, I just wanted to thank all of you for cooperating when I was a coordinator till the December, till last month. From this semester onwards, Professor K. Anand will be taking over as a coordinator. Of course, I'll be teaching courses as a teacher, course teacher, but Professor Anand will be the coordinator. Anything related to queries, all those things here you can contact me. Other than my course. Yeah.
Thank you, sir. Thank you for your valuable support, sir.
Yeah. Still, I will be supporting, but actually, you are officially you need to contact him only. I will not be able to respond anything. Anything related to this course, or still you can ask any help. Okay, but officially he is the coordinator. Okay, that's this semester onwards. We get generally goes on rotation every 2-3 years once they rotate. So he is going to be there for another this semester onwards. But you can contact me. It is not that you cannot contact, but as official, generally it is correct to talk to him or write to him only, not to me. Correct? Anything, but for the course related to this course, you can write to me, talk to me as per the hybrid electric vehicle. Program wise or your project wise, and because I'm guiding 4 students for the project one. Those students can talk to me all these things. But in general, anything related to project, when is the midsem happen, all those things you have to direct to Professor K. Anand, not to me. Okay. So since he is officially now he is the coordinator. Okay. But unofficially you can talk to me. It is not that you can, if you want something else also, you can talk to me. No issues. That's why I just wanted to thank this 2023 and 2024 batch, because my term as a coordinator is ended. Fine. Now, as I said in May, I welcome you all for this course, which is one of the most important course. We know that people are talking about alternate fuels. And because I joined ICNG Lab in 1984. Okay, December 1983 December. As an instrumentation engineer, I worked there for 9 years. And that time, many PhD scholars were doing different topics. Correct? You know, ICNG Lab were around 20 PhD scholars. A whole mechanical department had only 45 students, something. Out of that, 18 or 20 were from ICNG. That time, I'm talking 1984, 90s and all. Okay. So since I worked there for 8 years, because as you all know that I'm not a mechanical engineer, but I learned engines, combustion. I'm teaching, I do sensors, you know that I'm teaching courses. I can teach even IC engine course. I know because I did my PhD in developing ECU for SI engine. Indigenous ECU 20 years before, year 2003, I demonstrated in a motorcycle. Hardware, software, designing the fuel injection system itself, mechanical, this one, completely modifying the engine, the single cylinder sport engine. I tested on the test bed and all those things. So for my PhD, I learned IC engine course on my own. I never attended course. I took IC engine course book, standard textbook. I read for 3 to 6 months continuously about combustion, all those things. And so I learned myself. Okay. And of course, after that, I'm doing teaching all this thing. There's one thing. Now, why I'm talking is this: we are talking about electric vehicle, correct? Alternate fuel, dual fuel, and hybrid vehicles. All these things people started talking 40 years before. I'm talking 1984 itself. So in 1984, the one research scholar doing alternate fuel, methanol based, correct? Surface ignition, methanol fuel, correct? As a for diesel engines, 1984. Hydrogen as a fuel, pure hydrogen as a fuel. Nobody in India thought, even other aid, nobody talked. One professor called Nagalingam, he visited Germany, he was 1 year. When he came back 1985-86, he brought one metal hydride hydrogen storage unit. It was gifted by the German uses a DAD program with one dynamometer, all those things. So hydrogen as a fuel, pure, just to hydrogen alone, we tested on single cylinder diesel engine. Instead of diesel fuel, hydrogen. I'm talking 1988 something. Correct. So in IIT, we worked on methanol, ethanol, dual fuel, gaseous fuels, correct, and hydrogen as a fuel. In fact, I did a project along with one more professor. We modified 6-cylinder CNG bus engine for a Indian company. You know the Tata Motors. Now no problem, because I myself and one more professor, A. Ramesh, ICE engine, he was in charge for modifying the engine, because in Delhi, the Supreme Court told that a lot of pollution, diesel pollution, particulate pollution in year 2000 around the time. Correct? Too much of this one. They said they banned no diesel vehicle can enter, including cars. No diesel vehicle can enter New Delhi in NCR region, because pollution become too much, especially particulate matters. So they said, you use engines which produce less particulate matter. We all know that particulate matter is nothing but partially burned diesel particles. Correct. So gaseous fuel, if you use instead of liquid fuel, instead of diesel, it easily, already it is gaseous form. It mixes with oxygen. Combustion will be better. particulate matter production will be very, very minimal. Correct. This came in year 2000. That time itself, Government of India also was talking about alternate fuels, correct, to reduce global warming. That's what we are going to talk about it. Why the electric vehicle, hybrid vehicle came. That's why I'm just talking about that. In year 1996 or 94 in Kyoto, Japan, internationally, all the countries, heads of the countries met, and they were saying that the global temperature is increasing worldwide. Atmospheric average temperature of the atmosphere, which was around 1 degree or 0.5 degree a century ago, it was slowly increasing, and because of that, there is a climate conditions are changing. So there were a lot of issues, and many countries did not agree, but scientists proved that the atmospheric temperature increasing, what they call as global warming, and it is due to greenhouse gases produced by humans and also by nature. But humans are producing more than what nature is producing. They found that main thing is combustion of hydrocarbon fuel. We know that, again, I just wanted to say that it is methane and carbon dioxide are the two main gases which we call as greenhouse gases. The greenhouse gases are produced by decomposition of biological material, correct? Like plants or living organisms, correct? Or digestion, correct? We do when we eat food, digestion happens in the stomach. During that process, methane is produced, correct? Cow dung, all those things. Also, when it degenerates, it produces methane. And also, when the plant material due to earthquake, something, it goes inside the earth, this one, it also because the heat in the earth, inside the earth, and the water, all those things, again, start decomposing. We know that byproduct is the coal and also methane gas. We all know that if you dig coal, in coal mine, most dangerous problem is explosion due to methane gases. Methane gas will be byproduct of coal production, which is also will be concentrated inside the coal seams below 1.5 kilometer. When you mine the coal, the gas is released. If there is a spark, something, you know that many times coal mine, fire accident happened, blast happens because of this. Miners will get killed, all this thing happens. So that was a big issue too over the last 250 years. Correct. And the Davis lamp, you would have heard about in school text in physics, because when I was studying physics in my high school, Henry Davis, he invented Humphrey Davis, he invented a lamp. That time no electricity, kerosene, all those things. But if you take a kerosene inside, become methane, it can get fire inside coal mines. So he developed a protective, this one still I remember when I studied 6th or 7th standard. Safety lamp he produced. So methane is a byproduct. Please note that methane also another this one. And when we talk about this course, because we know that this course title itself is hybrid and electric vehicle technology, we are going to talk in two parts. First part will be what is a hybrid vehicle, what hybrid vehicle contains, and detail. The course detail already I will share tomorrow at this one. You can see that. What is a hybrid, series hybrid, parallel hybrid, all the types of hybrid, how to compute mechanisms, coupling to a correct engine with electric motor. It can be coupled seriously, parallelously. That means the gear arrangement, coupling arrangement, how to couple two energy sources, which is going to drive the wheels. So those mechanisms, how to calculate the torque and power, sizing of this one, what are different type of hybrid vehicles, the layouts, all these things we'll talk first maybe 15 to 20 hours. Subsequently, we'll be talking about electric vehicles, electric vehicle means we are talking different type of electric vehicles. Plug-in high electric vehicle, pure electric vehicle, like other things. There for another 20 hours, we'll be discussing about what are the different type of electric motors. Please note that engines already we had covered, correct? You would have studied a separate course by K. Anand, correct? You would engine and pollution, you would have talked. Then we have talked about autonomous vehicle. That time also first 10 hours I was talking about diesel engine, this one, correct? CRDA engine, petrol engine, TFI engine. Then also we talked about brakes, all those things. Engines already you have done your course, IC engine pollution and control by Anand. And 2023 batch, 24 batch will be definitely 1 hour before you would have listened. Right? The 24 batch would have started the course about IC engine. That's why we are teaching this course along with. So it will be easy for you to together. No, one batch already know IC engine, other batch learning together. We are going to. So I am not going to talk about IC engines. Of course, in introduction, I talked about 4 to 6 hours and this one. So the pending is to know more about the electric motors. What are different type of electric motors? And to electric motors, how to drive or control the speed of electric motor and the power or torque produce electric motor. For that, you need to control the electrical energy supplied to the motors. Correct? So that means from batteries, electrical source in electric vehicle. From battery, how the voltage and current, which is nothing but current, power, electrical power supplied to the motor, which in turn is converted to mechanical torque and mechanical power, which drives the vehicle or wheel. So for that, how to control, correct? That means we will talk about power electronic devices, correct? We may talk about these, what you call a power electronic semiconductor devices like diodes, rectifiers, how the diodes can be used as the rectifiers, and which can convert AC voltage, DC voltage, and also power drivers like PWM converters, SCRs, silicon control rectifier, FET MOSFETs, which is going to control the high current, high voltage supply to motor. For example, you take electric vehicle, pure electric vehicle, 100 kilowatt motor you are using. For example, 100 kilowatt means 1 lakh watts. We know that power electrical power P equal to V into I, voltage into current. Now, for example, the motor drives at 500 volts. Then the power divided by voltage of the current. You know that current is going to be 1 lakh divided by 500. 200 amps current will be supplied. So you need a battery pack which can give 500 volts and up to 200 amps current. But by controlling, we know that as you give more current and voltage, the torque produced by electric motor is going to increase, your vehicle speed increases, accelerate, decelerate. Right? So that's what the driver is going to by pressing accelerator pedal in electric vehicle also. Hey, say again, accelerator you're going to press and this one when the driver does. So how it is controlled? That means you need power electronics like your MOSFETs, right? SCR circuits, all those things. Then we will be talking about different type of energy storage devices. Means start with lead acid battery. What is a battery? Lead acid battery, how it works. But of course, nobody is using now lead acid battery for electric vehicle. But when the electric vehicle came some 20, 25 or 30 years before, that time lithium-ion battery was not invented, was not available commercially. And so lead acid battery was used initially. But we know the difficulties of lead acid battery. It takes a lot of charging time, and also it is energy efficient is very less, a lot of limitations. So we will see what lead acid battery, how it works, what is the process happens, the chemical equations, its advantage, disadvantage, how to charge, discharge, all those things we will see. Then the modern vehicle, we know that we are using lithium-ion batteries. That is the main power source. No, we are no more using lead acid battery. In between, some other batteries came, nickel, cadmium, all those things, but they're never used in electric vehicle. Directly lead acid from there to lithium ion, lithium copper. So we will see what is a lithium ion battery, what is different varieties of lithium ion, what is charging, discharging, the mechanisms, advantage, disadvantage like batteries. We will talk about it. Then, of course, the batteries modern battery, lithium-ion battery, is not like a simple lead-acid battery. It contains a lot of electronic and control systems, so that the charging, discharging should be controlled manner you have to do. It is not like lead-acid battery. If you overcharge or over use of more current to charge, quick charging try to do without proper control of temperature of the lithium-ion battery, it can burst into flames and it can burn. Correct? That is major accident will happen. So handling the lithium-ion battery, charging, discharging has to be done in controlled manner. So for that, there's a special circuit, particular battery management system. That's why lithium-ion battery costs more compared to lead-acid battery. Of course, it has a higher quick charging is possible, higher energy density compared for same size and weight compared to lead-acid battery. That is advantage. But this kind of disadvantage there. So there are varieties, right? Lithium-ion. So that also we'll talk. What is the battery management system? How they are working? These are the things we are going to cover in this course for next 42 hours. So as a first class, I just wanted to talk about first one or two classes. We will talk about general topic, why we need electric vehicle or hybrid vehicle, what it is, all those things. That's why I just started with this slide. We all know that when we talk about automobiles, all these things, or you switch on your TV, any news channel, whether Indian news channel or foreign news like CNN, BBC or anything, or go to magazines or internet website, people talk about what you call as global warming, correct, greenhouse gases, and suddenly we'll see climate changes. Every year, every 3 months once, international level or this one, people are discussing, government level, scientist level, or industry level, people are talking. So that's why I just start that first slide. Global community under pressure, I said, in fact, under tremendous pressure due to what you call as greenhouse gases production. And if greenhouse gases are produced and it is vented into the atmosphere, right? We know that atmosphere is from Earth's surface up to maybe some 100 kilometers, but we talk about the lowermost atmosphere. Atmosphere itself is extend up to 400 kilometers, approximately 300 to 400 kilometers. Exact number we'll see later. It is divided into 4 parts: ionosphere, topmost layer, stratosphere, like that. There are 4. This one, the lower range height of the sphere, right, is 10 kilometer, 10 to 12 kilometer, where the clouds are formed from. I'm talking about Earth surface or ocean surface up to 10 kilometer height. Correct. There only the clouds are formed, wind is moving fast, all those things, and air density is very high. Correct. At sea level, we know 1 bar. As we go upper, the density go on reduces. After 10 kilometers, we say it becomes very thin. Maybe after 20 to 30 kilometer height, the thin is so thin that you know that aircraft cannot fly. Only rocket can fly. Even we know that the Air Force jets, correct, fighter planes, which can fly in higher compared to commercial. Commercial plane, you know that they don't fly beyond 12 kilometer height. Maximum 10 kilometer. Correct, 35,000, 40,000, or worst case 50,000 feet is the normal allowed, where the atmospheric pressure, oxygen levels are sufficient, but it is definitely very low. Okay, and the density of air is sufficient to make the airplane to fly, because the lift is created by air for a given the wing area. When the aircraft goes beyond beyond some 15 kilometer height, correct, maximum they say 15, that is generally commercial don't go beyond 10 kilometer height, 10 to 12. Then for the weight, correct, if you say commercial plane 747 or Air 350, 380, big airplanes, commercial or military aircrafts, transport aircrafts, the lift generated is proportional to air density and also the wing area. So currently, of all this one cannot fly beyond 10 kilometer height. The fighter planes are where you know that they are just maybe to 30 tons, 40 tons, that is including the weapons, and they are big only to one pilot or two pilot. Their design go up to 60,000 feet, generally around 50,000, including Rafale, F-15E, whatever plane you see. There are hundreds of different fighter planes made different countries, including Tejas India is making. If you see the maximum height at which it can fly is around 50,000, 55,000 feet. Like around 60,000 is maximum, very rare. Normally 45 to 55,000 is this one. Beyond that, air is not there, sufficient density. Even though it is there, they cannot fly. Only thing is you have to go to rockets. Correct? Space also rocket. That is not our interest. But the atmosphere, lower atmosphere, right? We call this a stratosphere, where the main air is there, more air, amount of the air mass, in which the clouds are formed and the rain comes, all this thing happens, is affected by the greenhouse gases. Okay. What are the greenhouse gases? Before there are, these are main components. One is carbon dioxide, other one is methane, then CFC, which is used as a refrigerant air conditioners and fridges, and NOx, nitric oxide. These four gases are called as greenhouse gases. And you can see that this figure, because most of the figure I took it from internet. It is not my drawing. I try to acknowledge as much as possible, because any figure, if you see, generally it is from internet. I would have taken it is in public domain, and just for teaching purpose, I'm using in my slides. Okay. So the next thing is, you can see that out of these four gases, correct, main important greenhouse gases, we know that if you take atmospheric air, 77% by volume is nitrogen, N2, not NOx, pure nitrogen. 22% by volume is O2, pure oxygen. That they come together, they form around 78 to 79% approximately in volume basis. So even if you take remaining 1 or 2% volume, that is filled by all other this and right, including dust, right, water vapors, and carbon dioxide, methane, nitrous oxides, fluoride gases, any other gases, whatever you think, they form only around 1 to 2% of volume in the Earth atmosphere. Out of that, the available, the greenhouse gases alone is shown here. If you take the greenhouse, these four greenhouse gases, if you take as a 10%, which is around close to 1%, less than 1%, you take 1%, that is multiplied 100 times. Then if you divide, you can see that carbon dioxide main problem. Correct? The atmosphere is 81% of the atmosphere is, I am talking the 1% of the atmosphere gas, in which
Sir, you are writing something on the slide, sir. We are not visualized.
no, I am
You're
not
right.
writing, only
Okay.
showing it. You are seeing greenhouse, correct?
Okay.
I'm just
yes,
explaining.
yes, sir.
I'm
Right, sir.
not writing. So in this,
Thank
81% is carbon dioxide, and 10% is methane. Please note that methane is produced by decomposition of biomaterial, correct? Including digestion inside our stomach or any animals. Inside our stomach, digestion happen. Correct? The gases generated due to digestion. And for example, majority think people blame cows, horses, correct? Because billions of horses, cows are there throughout the world, correct? Of course, they produce milk, we eat meat from that, all these things. But when they are alive, they consume a lot of grass. The grass will be digested in the stomach of these animals, correct? Herbivorous animals, including elephants, whichever is deers, all those things, whichever is grass or leaves, plant the material. When it digests, it produces methane. Of course, we are also eating plant materials, correct? Greens, vegetables, all those things. When it digests, it produces methane in our stomach. That forms only 10%. And the nitrous oxide, due to lightning or engine emission, correct? CO, NOx by combustion, or any other factories wherever you produce nitrous oxide, they form 7%. and fluorinated gases using refrigerants and fridges, all these things constitute 3%. We are talking the greenhouse gases. If you take a 10%, what is the percentage contribution of the greenhouse gases? So you can see that carbon dioxide. From where carbon dioxide coming? Correct. Carbon dioxide comes primarily by burning fossil fuels. Correct. It is due to burning fossil fuels or wood or coal. If you burn carbon, what is carbon burning? Burning is nothing but colloquial name. Correct. We know that we call it a fire because it generates heat, all those things. But burning is nothing but the carbon or the, if you take pure wood or coal, it has carbon atoms. When you heat it and it burns, it joins with the oxygen molecule in the air. So it forms from carbon plus O2, it becomes CO2. So when you burn wood or coal, wherever, in your home, for cooking food, or in your factory, or inside the thermal power plants, if you burn, automatically going to produce CO2. Next is the liquid form or gaseous form. Okay. So LPG, correct? Natural gases contain methane. Methane contains CH, carbon plus hydrogen atoms. We call carbon hydrogen chain, molecular structure. Similarly, petrol, diesel, all this thing, correct? Carbon plus hydrogen. That's why we call hydrocarbons. They call hydrocarbon molecules. This anything which you from crude you convert into kerosene, diesel, petrol, or heavy oil, or jet fuel, or LPG gas, they contain CH. When it is pressurized and heated, and if sufficient heat is given, combustion starts. That's what we are doing in petrol engine, diesel engine, or in jet engine by compressing air. No? But why we are compressing with air? It need oxygen freely available in atmosphere. So they combine. Final byproduct is CO2. If you burn wood, coal, or hydrocarbons, we all know, and I need not explain. We have done many times. You have done a course. You are in the automobile company. I need not explain. The byproduct is CO2. But CO2 production should be stopped if you want to reduce the global warming. Correct? Global warming, because CO2 is a greenhouse gas. Okay. If the greenhouse gas is produced more and it is mixed or vented into the atmosphere from the engine or power plants or in the home after this one, and it increases CO2 percentage, correct? From 81%, it becomes 82, and like that go on increasing percentage compared to other greenhouse gases. And these gases, all these things, not all 3-4 gases, are called greenhouse gases. That's what I want to explain. What is greenhouse? This figure shows what is greenhouse. If you go to Lal Bagh in Bangalore or Ooty, Kodaikanal, or this one, you will see that there's a glass houses. They call greenhouses, glass houses. Actually, it's a building completely enclosed. Top, instead of having tiles or concrete, they will be the top roof will be made of glasses. So the sunlight can come inside this one. Inside that, they put exotic flower plants, all those things which require cold condition. Because India is a tropical country, even in the peak winter in South India or many places in Chennai also or Ooty, Kodaikanal, they can go sometimes 1 degree to a few days, but most of the time 15, 18 degrees. These beautiful roses or tulips, like which is there in the cold countries. I am talking northern hemisphere or in southern like Australia, New Zealand, or Canada, USA, Germany, Japan, all those things, cold places. Flowering plants will be very bright. The flowers will be brighter than the tropical countries. Right? So they look beautiful, roses, tulip, all those things. Those things you like it, correct? Human like beautiful flowers. So if I wanted to grow it in India or even in the places like Ooty, Kodaikanal, or any hill station, even though the temperature 4 degree, 5 degree, few days, but many times it become higher. So you need for example, Bangalore, correct? It is from sea level only 300 meters. So the temperature may be 20. That this one, you cannot grow the special plant flowering plants in the northern hemisphere, cold countries. So you need to create a condition. So that means sunlight should, all the plants need sunlight. So the sunlight, the picture, this shows that from the sun, light is coming, hitting on the flowering plant. So photosynthesis happens, they grow, flowers will come, you can go and see it. But you need to maintain the humidity also. Apart from temperature, also light should come. So it is a controlled environment. So that's why they call greenhouse. Because you are going to plant flowering plants, greenery. So that's why they call greenhouse. But the main thing is you wanted to maintain particular temperature, this one, apart from allowing light. So the major problem is from the sun, light heat comes, that will be stopped by the glasses, special glasses. They will not allow all the heat to go, except some amount of light alone, and they put humidity control, all those things. So that means, but apart from that, heat cannot go in. Also, whatever the heat inside cannot come out. Suppose suddenly outside, because the plants cannot, for example, outside temperature Ooty or Kodaikanal something, it becomes -5, -10. The flower will automatically will be destroyed. The leaves will be destroyed. Because very cold also plant won't grow. Very high temperature also not good. You have to maintain. So that means heat inside the room should not be come out, and similarly too much heat from outside should not go in. So it is specially made. So that's all called greenhouse. So Earth atmosphere also nowadays is becoming like a greenhouse. That's why it's a greenhouse effect. So this picture shows what is the greenhouse greenhouse effect on the atmosphere. You can see the Earth surface bottom, which is shown in brown color surface, and the from the surface up to certain height, maybe 15 kilometers, we call stratosphere, where the majority air, clouds, water, this one, vapor, all these things are there. And you know that when in the morning, when sun rises, the light comes and hits the earth, but the sun heat light is coming, passing from the 8 kilo. It takes 8 minutes. We know that millions of kilometers travel from the sun, reaches the earth surface by traveling to the atmosphere. While it is going, apart from giving the light and the heat on the earth surface, it also heats the atmospheric air, correct? In which you have the nitrogen, oxygen plus these gases. Okay. We know that daytime, that means in daytime sun shines, morning 6 o'clock sun rises. For example, evening 6 o'clock sun sets in one side of the earth, correct? For example, Asia, Europe, all these things. That time America will be night time. So that time the atmosphere in this area is get heated up. Once sun sets, what will happen? There's no heat input is coming. So from the air heated in this part of the earth will start giving back the heat back to atmosphere. That is space, correct? You know the space is very cold. That's why in aircraft, with all those things, if you go beyond some 100 kilometers, the temperature -100, -200 degrees this one Celsius, Fahrenheit. It can go to even cold, correct? So you need a protective cloth. There's astronauts, all those things. They wear special coated heating. The will be there. So that means it is very cold from atmospheric air in this part of earth, from where the heat of whole day gives back the heat. Okay. So we know the heat is coming from the sun. Majority heat is coming from infrared, correct? Not in the visible spectrum. It is infrared light, which is also emitted by sun. That's what is heating there. Now it goes back. Now, heating daytime, night 12 hour it is getting cold. But of course, America, that area side of the sun is getting heated because sun is shining. But this side it has to go back. But when the morning 6 o'clock, because for example, first day today, the earth temperature or atmosphere temperature in Chennai was around 20 degree. When sun rises, evening it becomes 30 degree. Correct? It gets heated up and sun is settled. Now the atmosphere heat is going back to the space. That means where the heat is stored, the gas molecules, nitrogen, oxygen, these gases and water vapor, all these things were storing the heat to daytime, and they release the heat back. As I told you, these gases, which is called greenhouse gases, they release the heat slowly. They absorb the heat slowly and also release the heat slowly compared to nitrogen and oxygen. molecules. Even though they are majority, please note that this is only 1%, all the gases together. But every day they get heat and the whole night they release it back, correct, to the space. But morning when again sun comes, previous day it was 20 degree, it was heated to 30 degree. Whole night it release the heat back, nitrogen, oxygen, all these things. But the carbon dioxide, the methane gases, they keep some amount of heat. They don't release, they are slow discharge. Heat discharge is very slow compared to oxygen, this one. So because of that, next day when sun rises, the atmosphere temperature was not 20 degree, it may be 20.01 degree or not 1 degree. 0.01 degree is more in a day, for example, I say. So again, sun heats for 12 hours, the temperature went to 30.01 in the end of the day, correct? So again, heat is given back the whole night, but carbon dioxide, these gases retain little more. The next day, the morning, instead of 20 degree, 20.01, it may be 20.002, not 2, correct? 0.01 degree. Like this, every day, these greenhouse gases retain some of the heat they receive in the daytime. So because of that, the average temperature atmosphere increases day by day. Please see that very, very small. But per day, I'm talking 0.001 degree centigrade. You per year 365 days, per 10 years, like that. That means if more carbon dioxide or methane gas is there in the atmosphere, the average temperature atmosphere start increasing day by day. This is called as global warming. This is happening due to these gases. Please note that these gases are there in the Earth atmosphere for last millions of years. But that time, the carbon dioxide produced due to forest fire, humans were not there. Correct. We know the human population known history is only 5,000 to 7,000 years, starting from Mohenjo-daro, Harappa, or Mesopotamians, Egyptian civilization. We all know humans' existence. Maybe modern human, we are talking 10,000 years. Before that, people were 40,000 years. We say Homo sapiens came from Ethiopia. People are talking. We know the first humans from monkeys because Darwin theory, all this thing is proved. They say 1 million year, first human Homo sapiens came out of the monkey. This one still monkeys are there. Yes, a special type of monkey we become a humans, right? So our this one is only 1 million year they say from Ethiopia. They have proven, correct? First human skull they found, it is something around 1 million, 1.2 million years from Africa, Ethiopia. From there only worldwide they spread, humans spread. Homo sapiens, present humans, we are all Homo sapiens. We started using fires maybe 40,000 years, they say. Before the fire also, we don't know. We were like animals only. We are eating raw food, only hunting. No agriculture is only 10,000 years before. Before the human did not know agriculture. Correct? The extensive agriculture after 5,000 years. Mesopotamia, Egypt, all these things. Right? Before that, we were eating just like other animals, hunting and eating are fruits available in the forest. That's right. So that time we did not create carbon dioxide by ourselves. Maybe we were burning little bit of cooking food, something, all those things with wood, correct? But the actual CO2 emission is by modern humans after invention of the steam engines, then industrial revolution, correct? Where the coal was burned to produce steam to run the ginning factory, cotton factory, all the industry were driven. Fact is that time IC engines were not invented. Around 1900 beginning, Otto from Germany, Rudolf Diesel from Germany, Austria, they invented diesel and petrol only 125 years before. Then they start powering the automobiles, engine, trains, correct, and also ships everywhere instead of the steam. Ships where we were burning coal, we started burning hydrocarbons, petrol, diesel, kerosene, whatever the possible. Jet engines came, all these things. For last 100 years, humans are producing more and more carbon dioxide, which then for last 1 lakh year or something, which were produced by forest fires or humans by cooking, all these things. So we are the main issue problem. Current humans or current generation of humans for last 100 years are responsible for creating so much carbon dioxide by fossil fuels. Okay. So if you burn fossil fuel, right, any form, or jet fuel or gaseous fuel, nitrogen, all those things, definitely you are going to produce CO2. But up to 1995, people were thinking that we know the three-way catalytic converter, correct? SCR, correct? Yeah, for SCR from diesel engine, NOx reduction, NOx reduction, CO2, CO, NOx, and HC emission will be removed by three-way catalytic converter because unburned, all these things. That's what we thought as a toxic gases for last 100 years. But 1995, and we said that if I make a perfect combustion in a petrol engine, diesel engine, or a gaseous engine, LPG, or this one, what should be output? The petrol or diesel per oxygen, you are supposed to get CO2 plus H2O. Already last previous semester I told, you can make free this one soda. You need not buy 30 rupee, 40 rupee, 300 to Coca-Cola, Pepsi. Correct? If the engine works perfectly, in the tailpipe, you will get soda free of cost. But perfect combustion is not possible because of misfiring or the contamination in the fuel. There are many things. Combustion is very difficult. Already we know. That's why you are studied a course on IC engine combustion pollution control. So pollution control till now you are talking about CO, HC, NOx, whether petrol or diesel or jet engines. But we thought that CO2 production is no problem. CO is an inert gas. It is not harmful. We are drinking. Yes, so along with soda, water with this one. It is not. But 1995 or 80s, they found that it is a greenhouse gas. Correct? Greenhouse gas is too dangerous in long term. Because of that only, this is happening. Correct? Unpredictable weather, severe cyclone, cloud busting, floods, Arctic, Antarctic ice is melting, and also Himalaya ice and Alps, Rocky Mountains, wherever ice is there, high altitude mountains, they are also melting. Gangotri, the starting point of our Ganges, has moved 3 kilometers originally. If somebody would have gone to Gangotri, Gomukh they call it, where the Ganges starting point in Himalaya, that is retreated 3 kilometers in last 200 years. The start Gomukh was 3 kilometers before, now it is going back. They say within another 50 years or 100 years, river Ganges, Yamuna, most of rivers will dry up because no ice will be there in Himalayas because of global warming, apart from Antarctica. If too much ice melts, they say the Antarctic ice, Arctic ice, and also the Himalayan, all these things melts because of global warming, because of production of CO2 by burning fossil fuel, whether engine or power plants, wherever it is, then the sea level is raised by 20 meters. They say up to 20 meters, not 2 feet. 20 meters from the current level, if all the ices are melts, but that can happen within another 20 to 30 years. Already, lot of simulation results are showing. Correct? So in that case, many of the city, including Chennai, will not be there. Any coastal disease, New York, Washington, all the coastal cities, major population up to, they say, sea level water will go inside 2 to 5 kilometers from the current beach, seashore. It can go because 20 to 30 meters. So only way to stop CO production is not to burn coal, kerosene, or IC engine should not be there. You should not burn coal. Thermal power plants should be completely closed. IC engine, ship or aeroplane or automobiles or trucks, it should be removed, and total banning of burning of hydrocarbon fuels and wood and this one. That should be done within 20, maximum within 20 years. Otherwise, you cannot reverse. That's what they're saying. Because of this only, people are moving towards electric vehicle, all electric vehicle. Okay. And you cannot go from regular vehicle to electric vehicle. There are problems with energy source, nothing but battery. Battery, energy density, charging, discharging cycle, cost, all these things are playing. That is why for last 30 years, slowly, we have come regular IC engine based vehicle. We are going to hybrid vehicle. From hybrid vehicle, we should go for pure electric. But pure electric also not going to be useful unless you produce the electricity to charge your battery using renewable energy sources, not by producing electricity by burning oil or coal in the thermal power plants. Thermal power, that means you need to produce electricity, solar energy, wind energy, geothermal energy, or wave energy. These four are called renewable energy because wind is freely available, waves are freely available, sunlight is freely available, and geothermal energy also freely available. There's no need to produce, and they don't produce CO2, global the greenhouse gas. So if I use these heat sources to generate electricity and charge my batteries, electric vehicle, whether it a plane, rocket, or bus, or car, or this one, or ship, or submarine, all the propulsion systems with electric motors, then we can stop global warming. Then Earth can be protected. Otherwise, they say within another 100 years, the average temperature, summer temperature go to 50, 55 degrees around the world. Humans cannot live. Not only humans, plants, many animals will die, exterminated. It can go to 60 also within 100 years, they are saying, if I burn the fuel. That is why many countries are, but including India, is asking people to go electric. But going to electric is not easy. That's what we are going to study. What is a hybrid vehicle? What is the electric vehicle? How they are working? What is a battery? What is a present battery? Of course, invention should be made, improving efficiency of the new type of batteries, new type of motors. Slowly, ignoring or reducing the use of IC engines, whether it's stationary application or moving application, transportation, whether air, ground, or the ocean. Correct? No more engines. That's what they want worldwide. All the governments. It is not only government, it is to protect the earth. That's why we are talking. Okay. So because of that only, everywhere they say, we are also introduced this course called electric and hybrid vehicle. I will stop here. I think time up. Tomorrow we'll continue more about introduction. What is a greenhouse, green vehicle, green factory, like that. We'll talk introduction more about it. How the electric vehicle. In fact, the first automobiles are not IC engine based. Just I will show one glimpse. This is you can see the New York Street. Correct? New York Street around 1900. That time only petrol diesel engine was implemented. You can see the cars. None of the car is IC engine based. Correct? First electric vehicle, you can see 1832. Correct? The inventor name is Robert Anderson. Correct? You can see that they are driving an electric car. The first transportation modern is electric vehicles, electric cars. Then IC engine invented. Then IC engine based cars, truck, ship, everything came. Again, we are going back to electric. It is a cycle, vicious cycle. Correct? We are going back to, that's why I started one show figures. All this thing we'll discuss tomorrow. Please give attendance as a chat message. You know that before leaving, please give a chat message. See you tomorrow by 6 o'clock. We will continue the introduction, another 1 or 2 classes. Then we'll dive deeper into hybrid vehicles. Then we'll talk about electric vehicles and components, power electron, all these things. Okay.
Thank you, sir.
I love you. See you tomorrow by 6 o'clock.
Thank you.
Thank you.
Yeah, all of you, please give the attendance without fail as a chat message. That is the attendance record. Okay, I am going to close.